Welcome you all in lecture number 22 of Engineering Mathematics 1 MTL 1025. In this lecture we will going to discuss the reduction formula of x to the power n x to the power n ex dx, and second one, that is x to the power n sin x or cosine x. Okay, and then we will discuss about the gamma function. Right, now let us see what is the reduction formula for x to the power n e to the power x dx. Say it is I. Okay, see, x to reduction formula of x to the power n e to the power x dx is x to the power n e to the power x minus n into this. If we call it this integral as in x to the power n e to the power x dx. Now apply Euler rule that algebraic function and exponential function is present. So consider this is the first function, algebraic. So this one is algebraic function, this one is exponential function. Okay, then first function, integral of second minus derivative of first function into integral of second function or integral. Okay, then this is equal to x to the power n ex minus n into integral of x to the power n minus 1. Integral of ex is ex and dx, right? And say in is equal to x to the power n ex minus n into, what is this integral? This integral is in minus 1. Okay, so this is the reduction formula. Okay, this is the reduction formula for this one. Okay, now come to the second part. This is the reduction formula for this. Okay, now see the reduction formula of x to the power nx cos x, and in similar way we can evaluate the reduction formula of x to the power n sin x dx. Okay, first see x to the power n cos x, then the first function, same rule, Euler rule. First function is x to the power n and second function is cos x. So first function, integral of second, what is integral of? That is the first function xn, integral of cos x dx minus derivative of first function x to the power n into integral of second function cos x dx, that is dx. Okay, so this is x to the power n, integral of cos x is sin x minus derivative of x to the power n into x to the power n minus 1. Integral of cos x is sin x. Okay, so x to the power n sin x plus, again you integrate this. This is the first function and this one is the second function. So first function is x to the power n minus 1. Integral of sin x, that is minus cos x, so this is positive, minus derivative of, right, minus derivative of x to the power n minus 1, that is, see this integral in this way. Okay, x to the power n minus 1, integral of second, integral of second, that is sin x minus cos x, minus derivative of first function x to the power n minus 1, n minus 1, x to the power n minus 2, integral of sin x is minus cos x, right, dx. Okay, so using this minus, this one is the minus, this is plus, so again, right, using this one, this minus and this minus become plus, and this minus and this plus become minus. Okay, so this is x to the power n sin x, n into x to the power n minus 1 cos x minus n into n minus 1 integral x to the power n minus 2 cos x. And what is this? This is in minus 2. Okay, so the reduction formula in is equal to x to the power n sin x, n into x to the power n minus 1 cos x minus n into n minus 1 into in minus 2. This is the reduction formula for x to the power n cos x. And similarly can evaluate the reduction formula for x to the power n sin x cos x, x to the power n sin x. Okay, this is homework. Okay. So if we evaluate the reduction formula for the definite integral, if the limit is 0 to pi, then this in becomes this one. Okay, now see the gamma function. What is gamma function? Gamma function is defined as, right, gamma is a function, right, domain 0 to infinity, and this is the real number. Okay, then gamma is defined as, gamma is denoted by this notation gamma, right, we can call it capital gamma, and gamma of any number n is equal to integral of 0 to infinity e to the power minus x, x to the power n minus 1 dx. See, this is the definition of gamma function. Okay, this one is the definition of gamma function. Gamma of n is equal to integral 0 to infinity e to the power minus x, x to the power n minus 1 dx. Okay, then see, what is gamma of 1? Gamma of 1 is equal to integral 0 to infinity. See, gamma of 1 is 1. How we can prove it? Integral 0 to infinity e to the power minus x, x to the power, what is the value of n? That is 1, 1 minus 1 dx. Then this is equal to integral 0 to infinity e to the power minus x, x to the power 0 is 1 dx, right? Then what is this? E to the power minus x divided by minus 1. Okay, 0 to infinity. This is equal to minus e to the power minus infinity minus e to the power 0, right? What is e to the power minus infinity? That is 0. And what is e to the power 0? 1, right? So it is minus 1 and minus of minus 1 is 1. So gamma of 1 is equal to 1. Okay, gamma of 1 is equal to 1. Okay. Similarly, we can evaluate gamma of 2 also. What is gamma of 2? Integral 0 to infinity e to the power minus x, x to the power n minus 1, that is, right? And use the, either you integrate it or use the reduction formula, general formula, means integral 0 to infinity x to the power n e to the power minus x dx. Make the reduction formula of this, right, and use this, right? For different value of n you can use it. Okay. Now see the second property. Gamma of n plus 1 is equal to n into gamma n if n is not integer. Not integer means we are talking about the positive integer, right? And gamma of n plus 1 is equal to factorial n if n is non-negative integer. Okay, it is non-negative integer. Then what is gamma n? Gamma n is integral 0 to infinity x to the power n minus 1 e to the power minus x dx. Yes. Then integrate it by parts, considering the first function and second function. So first function, integral of second. What is integral of second? E to the power minus x divided by minus 1. And what is the limit? 0 to infinity. Yes. Then differentiate x to the power n minus 1. n minus 1, x to the power n minus 2, e to the power minus x divided by minus 1. Okay. So see, what is the value of this term? The value of this term, see, since it is x to the power n minus 1, x to the power n minus 1. So we can't use infinity to the power n minus 1. This is the wrong term. Okay. So this term is x to the power n minus 1 e to the power minus x. Then this is equal to x to the power n minus 1 e to the power x. Okay. See, this is the polynomial. What is numerator? Numerator is polynomial. What is denominator? Denominator is exponential. Exponential function exponential function always dominates the polynomial after certain step. Okay, after a specific time or after a certain time period, this exponential function always dominates the polynomial function. If this polynomial is dominated by exponential, then this term x to the power n minus 1 e to the power x tending to 0. Okay, as n tending to infinity. Okay. So see, now this is equal to, okay, this is equal to limit x tending to 0. Limit x tending to 0, x to the power n minus 1 e to the power x. This is nothing but this is 0. Okay, so this whole term is 0. This whole term is 0. Okay, so this term is 0 minus n minus 1. This is minus, so this become plus 0 to infinity x to the power n minus 1 e to the power minus x dx. Okay, then what is this term? See, integral 0 to infinity e to the power minus x to the power n minus 1 dx. This is equal to, see how we say that this is gamma n by definition, and x to the power n minus 1, this becomes the gamma. Now if this term is integral 0 to infinity e to the power minus x to the power n minus 2, so n minus 2 you can write it n minus 1 minus 1. So this term, right, says that this is gamma n minus 1. Okay, so this is gamma n minus 1 into gamma n minus. So gamma n is equal to n minus 1 into gamma n minus 1. If we replace n by n plus 1, be replaced by n by n plus 1, then the left hand side become n plus 1, right hand side n minus 1 becomes n and gamma n, right? So gamma of n plus 1 is equal to n into gamma n. Okay, again in this equation 2, okay, in this equation 2, replace n by n minus 1. Okay, in this equation 2, replace n by n minus 1. What it becomes? It becomes n minus 1 gamma of n minus 1 is equal to n minus 2 gamma of n minus 2. Right? Again replace n by n minus 2. So this becomes n minus 2. Again replace n by n minus 1. Okay, sorry. Then this is equal to n minus 2, n minus 3 gamma of n minus 3, continuing in this. Okay, gamma of n minus 1 is this, and gamma of n minus 2 is equal to n minus 2 gamma of n minus 2. Okay. Similarly gamma of n minus 3, so dot so on. So gamma n is equal to n minus 1 into gamma of n minus 1. N minus 1, this gamma n minus 1 is equal to n minus 2 gamma of n minus 2. This is n minus 1 n minus 2. This gamma n minus 2 is equal to n minus 3 gamma of n minus 3, right? Dot so on. This becomes n minus 1 n minus 2 n minus 3 dot so on. At last this becomes 3 2 1 and gamma of 1. What is gamma of 1? Gamma of 1 is 1. So this becomes n minus 1 n minus 2 n minus 3 dot so on, 3 into 2 into 1 into 1. Okay, and what is this? This is nothing but factorial n minus 1. So what is gamma n? Gamma n is equal to factorial n minus 1. Replace n by n minus 1. Replace n by n minus 1. Sorry, n plus 1. Then this is equal to gamma of n plus 1 is equal to factorial n. Okay, so gamma of n plus 1 is equal to factorial. Now see some problems. Okay, first start from this fourth one. Okay, this one is here. So fourth, what is gamma of 7 by 2? Gamma of 7 by 2, we can write it 5 by 2 plus 1, right? It means that is compare it with the gamma of n plus 1. And what is gamma of n plus 1? N into gamma n. What is n? If we compare 5 by 2 plus 1, n is equal to 5 by 2. Then this is equal to 5 by 2 gamma of 5 by 2. Right? 5 by 2. What is gamma of 5 by 2? 3 by 2 plus 1. This is equal to 5 by 2. What is this? 3 by 2 and gamma of 3 by 2. What is gamma of 3 by 2? Sorry, 5 by 2, 3 by 2. Gamma of 3 by 2 is equal to gamma of 1 by 2 plus 1. Then this is equal to 1 by 2 gamma of 1 by 2. Okay. So this is 5 into 3 into 1 divided by 2 to the power 3 gamma of 1 by 2. Now later on we will prove gamma of 1 by 2 is equal to square root of pi. Right? In next lecture we will prove gamma of 1 by 2 is equal to square root of pi. Okay. So the value of gamma 7 by 2 is 5 into 3 into 1 divided by 2 to the power 3, that is 15 divided by 8 into square root of pi. Okay. So this is the gamma of 7 by 2. Okay. Now come to this point, gamma of minus 1 by 2. What is gamma of minus 1? By definition of gamma function we can say this is the undefined. Okay. But we know that gamma of n plus 1 is equal to n into gamma n. Right? This relation we already proved. Right? Gamma of n plus 1 is equal to n into gamma n. Right? Then using this relation, we have to evaluate gamma of minus 1 by 2. So replace this n by gamma minus 1 by 2. So what happened? Gamma of minus 1 by 2 plus 1 is equal to minus 1 by 2 gamma of minus 1 by 2. Okay. See, we know this relation. We already proved it. Then what is gamma of minus 1 by 2? If we use this relation, we know that this relation is true. If we use this relation and putting n is equal to minus 1 by 2, then we got this. Okay. Then gamma of minus 1 by 2 plus 1 is equal to gamma of 1 by 2. Yes. This is equal to minus 1 by 2 gamma of minus 1 by 2. And gamma 1 by 2, I already told you gamma 1 by 2 is square root of pi. Now, which we will prove in our next lecture. So this is gamma 1 by 2 into minus 2. So this is equal to gamma of minus 1 by 2. Okay. So this is the value of gamma of minus 1 by 2. In this way, can we prove can we find what is the gamma of minus 3 by 2? Whether it is possible? See. Gamma of minus 3 by 2 is equal to, use the relation, gamma of n plus 1 is equal to n into gamma of n. Okay. Then this gamma minus 3 by 2 is equal to, okay, replace n by 3 by 2 is minus 3 by 2. We use n minus 3 by 2. Then this happens minus 3 by 2 plus 1 minus 3 by 2 gamma of minus 3 by 2. Okay, no problem. This is equal to gamma of minus 1 by 2. Yes, this one is gamma of minus 1 by 2. And this term, take it left hand side, this becomes minus 2 by 3 is equal to gamma of minus 3 by 2. Then this is equal to minus 2 by 3 into. Now gamma of minus 1 by 2 means what? Gamma of minus 1 by 2 is minus 2 into square root of pi. This is gamma of minus 3 by 2. Then this is equal to 4 by 3 square root of pi is equal to gamma of minus 3 by 2. Okay. Okay. Now, what is gamma of 15 by 2? For gamma 15 by 2, we have to evaluate gamma of minus 5 by 2, minus 7 by 2, minus 9 by 2, minus 11 by 2, minus 13 by 2. After evaluating these terms, we can evaluate gamma of minus 15 by 2 also. Okay. Now see, what is gamma of 0? What is gamma of 0? See, if we replace n by 0, if we replace in this formula, replace n by 0, then this is equal to 0 plus 1 equal to 0 into gamma 0. Okay, and whether it is possible to evaluate this one? Okay, by this formula it is not possible to evaluate. Okay. Okay, we will stop here. Next lecture we will discuss some more properties of the gamma function and some related example of the gamma function. Okay.